Hey everybody, this is a problem on finding the electrostatic force on a single charge from two other charges, and this is a one-dimensional version of the problem. So let's get started. Three charges are on the y=0 line of the coordinate plane. The first is 2.00 millicoulombs at x equals 0 meters. The second is 4.50 millicoulombs at x equals 0.5 meters. The third is -3 millicoulombs at x equals 1.5 meters. Find, well, A, sketch a diagram of the charges. B, draw a free body diagram for charge 2. Identify which charge the electrostatic force originates from as a subscript. For example, the force from charge 2 applied to charge 1 would be F sub 1, comma 2. Find the magnitudes and directions of the forces on charge 2, and find the net force on charge 2, magnitude and direction. So let's just get started. Charge 1 is 2 millicoulombs, so I'm going to label that in red, and it's at x equals 0. So here's my charge. Q1 equals 2.00 millicoulombs, and it's at x equals 0, so I'm just going to label that x equals 0 meters. Charge 2 is -4.5 millicoulombs at x equals 0.5. So that's negative. I'm going to do that in blue. Q2 equals -4.50 millicoulombs. And the position is x equals 0.500 meters. And charge 3 is -3 millicoulombs at x equals 1.50 meters. It's also negative, so I'm going to do that in blue, and I'm going to try and do it approximately to scale, but this is not going to be exactly to scale. Q3 equals -3.00 millicoulombs, and our position is x equals, what is it, 1.50 meters. Okay, that's part A done. Part B, draw a free body diagram for charge 2. Which charge, and label the forces basically. So I'm going to do that in green. Charge 2 and charge 1 are going to feel a force, and since they're opposite charges, there's going to be an attractive force. So there's going to be a leftward force. It's going to be the force on 2 from 1. Now this is also not to scale. Charge 3 and charge 2 are both negative, so there's going to be a repulsive force. So I'm going to draw another arrow down here, kind of pointing to the left. Force on charge 3 from, whoops, it's actually the force on charge 2 from 3. Okay, so we have two leftward forces on charge 2. Next up, we need to find the magnitudes and directions of these forces. I'm going to scroll down a bit. And we're just going to use Coulomb's law for that. So I'm going to break it down into two parts. Force on 2 from 1. Well, we're going to use Coulomb's law. We know F equals K QQ over R squared. So I'm going to do QQ over R squared. And in this case, we're looking at charges 1 and charge 2. And so the R is also going to be the distance between charge 1 and 2. We plug that in. K is always the same, 9, actually let's do 3 sig figs. To 3 sig figs, it's 8.99 times 10 to the 9. Charge 1 is 2.00, and it's millicoulombs, so times 10 to the minus 3 coulombs. Charge 2 is -4.50 times 10 to the minus 3 coulombs. And the distance between charges 1 and 2, well, it's between 0 and 0.5 meters, so that distance is just 0.500 meters, and that whole distance is squared. That'll give us the force on 2 from 1, or the magnitude at least. Plug it into a calculator. 8.99 times 10 to the 9 times 2 times 10 to the minus 3 times -4.5 times 10 to the minus 3 divided by the quantity 0.5 squared gives us a pretty significant force of the force is going to be negative 3.24 times 10 to the 5 newtons. Now this negative sign just means it's attractive, so let's just be a little bit clearer and do the magnitude and direction. The magnitude is 3.24 times 10 to the 5 newtons, and the direction, we already found that the direction is to the left. And that's the force on 2 from 1. So that's part of our work. We need to do the same thing between charges 2 and charges 3. So let's find the force on 2 from 3. It's still going to be Coulomb's law. So that's going to be K, 9 times 10 to the 9, 3 sig figs, 8.99 times 10 to the 9, times Q2 times Q3. Q2 is negative 4.50 times 10 to the minus 3. Q3 is negative 3.00 times 10 to the minus 3 coulombs, divided by the distance between Q2 and Q3. From 0.5 to 1.5, that distance is just subtract them. 0.500 meters. That's not right. 1.5 minus 0.5 is 1.00 meters. That whole thing squared. We plug in, we get our answer. 8.99 times 10 to the 9 times negative 4.5 times 10 to the minus 3 times negative 3 times 10 to the minus 3 divided by the quantity 1 squared gives us 1.21 times 10 to the 5 newtons. That's positive because it's repulsive, but we also know that the direction is to the left, so let's just write that. Left. That's the force on 2 from 3. Okay, so that's part C. D, we need to find the net force. And we know that F net is just the sum of all the forces. We know both of the individual forces. Since they're both in the same direction to the left, we just add them all up. So our net force is just F21 plus F23. Add these two numbers up, and highlight them in green to get our net force. Just going to go straight to the calculator. 3.24 times 10 to the 5 plus 1.21 times 10 to the 5 gives us a net force of 4.45 times 10 to the 5 newtons. And since they're both to the left, our net force is also to the left. Just basic Coulomb's law and 1D vector addition. Hope that was helpful. Bye.